Good day, everyone. We are the Robotics Club of the Junior Philippine Society of Mechanical Engineers, or JPSME, and we are here to show you what we learn in our club. Today, we will talk about the Arduino. Most of the projects that our members do have Arduino in them. First, let's familiarize the basic knowledge needed to be able to work with Arduino. A microcontroller is a single integrated circuit that is typically used for a specific application and is designed to implement certain tasks. Arduino is a microcontroller board that allows you to perform electronics projects easily. It consists of a programmable circuit board and an IDE, or integrated development environment, to upload your personal code into Arduino. Now, you may ask, what are the uses of an Arduino in our everyday life? First, you can easily automate simple tasks at home like steering and pick up trashes. We can also use the Arduino to make a device that wirelessly controls your gadgets at home, such as an electric fan. Lastly, you can make awesome toys that uses your knowledge in robotics, such as Somobots. But why would anyone use Arduino compared to other boards like this? An Arduino is simple to use, and yet it is inexpensive compared to the things you can do with it. It also uses a simplified C++ language that makes the beginner programmers easy to learn and adapt. The pictures shown here are the different models of an Arduino depending on the application they are intended to be used for. The most popular one is the Arduino Uno, and it is used in a lot of projects due to its size and number of pins you can use. Next would be the Arduino Mega, a bigger model of the Uno that allows more pins compared to the previous model. This is usually used in bigger projects since it can allocate more sensors and actuators. Next are the smaller models of Arduino, namely the Nano and Mini. Based on their names, they are very small that it can easily fit in small compartments like a small handheld device. The last one is the Arduino LilyPad. Its uses are mainly for devices that are wearable. It can be sewn into textiles and add sensors or conductive threads. So now, let's talk about the basic parts of an Arduino. First is the USB port. This is where you attach or connect the USB cable from the computer so that you can use the IDE that can change the code of the Arduino. Next is the power input. This is where you plug in a power adapter when the device needs more power than the USB port can give. Next part is the Atmel microcontroller. So this is the brain of the Arduino. Next is this in-circuit serial programming. Another part would be the power supply. So this is an external power supply other than the power input. So there are two types of inputs and inputs in this board: the analog input and the digital input. While the analog input only receives inputs, the digital can receive and output. Now let's emphasize a little bit more about digital or analog. So digital means that a quantity can take specific levels of values with specific offset between each other. Basically, it means that it can only give you the maximum or the minimum that the board can give. So for the Arduino, it can only give 0 and 1 output, or it can only receive 0 or 1 input. While analog, on the other hand, means that the quantity can take any value between its minimum value or the maximum value. And in this case, the minimum value is 0 and the maximum value is 1023. Therefore, when the input of the analog, it is always between 0 and 1023. Another feature of the Arduino is the pulse width modulation, or the PWM. You can see that the digital inputs and outputs have a small wave sign in them. This is what we call a tilde. So what it means is that it can control the brightness or the speed of a fan. Like for example, in this one, this is what we call a PWM signal. As you can see, the LED grows dimmer and then goes back brighter. So that is what it can do, and it can adjust the intensity of the LED. So when you use it in a fan, you can change the intensity of the fan to slow, moderate, or high using that signal. Digital signal, on the other hand, is only an on or off signal. So as you can see on the right side, you can only set it to be on or off. So we talked earlier that the Arduino have this IDE. So this is the Arduino IDE and sketch overview. So this is where you decide or you edit the program that you will upload to your Arduino. So this is the basic syntax in the Arduino, the void setup and the void loop. For the void setup, it is used to indicate the initial values of the system while starting. So when you in the void setup, you can put the initial value like the LED is turned on or the LED is turned off. While the void loop, it contains the statements that will run whenever the system is powered after the setup. So when you put in the void loop, that after 5 seconds the LED will turn on, then another 5 seconds will turn off. So it will continuously repeat that loop of 5 seconds interval of turning on and off the LED.
Hello, I will be discussing about basic programming. So the first thing we're going to discuss is variables. So what is a variable? A variable is a container that has a value that can change depending on the conditions or information passed on to the program. You can think of it as a bucket, where you can place things based on the type of the bucket. In this case, adding a new item will replace the old one. Variable also allows you to take out items anytime. Examples are int equals 90 and int10 equals 0. Once the variable has been declared, you can easily change it later. Here is an example using Arduino. First, we have the variable LED that is assigned to digital pin 13. Then we have the function named setup, where we will write the code to assign the different pins of the Arduino to input or output, and also write the code for things that will only be run once. In this example, we are assigning the variable LED, which is pin 13, as an output. Next is the loop function, which is where we'll write our main program, and it will loop the codes until the Arduino is turned off. Here we are changing the LED to turn on, wait for 1000 milliseconds, then turn off, and wait again for another 1000 milliseconds. Next is data types and operators. There are different types of variables. First is integer, which is denoted by int, and is used to contain counting numbers ranging from negative 32,768 to 32,767. Example is int x equals 1200, which creates a variable of type int with a value of 1200. Next is character, which is denoted by char and is used to contain different characters. For example is char c equals r, which creates a variable of type char with a value of r. Then we have long, which is denoted by long, and an extended size version of number storage. Example is long u is equal to 199,203, which creates a variable of type long with a value of 199,203. Last is float, which is used to contain decimals. Example is float num equals 1.291, which creates a variable of type float and a value of 1.291. Next, we have the different symbols used for different functions. First, we have the symbols for the math operators, plus, minus, multiply, and etc. Then the symbols for logic operators, for equal to, not equal to, and or. Then the symbols for comparison operators, equals, greater than, less than, and etc. Here is one function that is used in almost all Arduino circuits, the digital read. It reads the value from a specified digital pin, either high or low. In this example, the digital read is used to check if the button which is assigned to digital pin 2 is pressed. Next is the analog read, which reads the value from the specified analog pin. It can read input voltage from 0 to 5 volts and integer values from 0 to 1023. In this example, analog read is used to measure the current value of the potentiometer. Next we have the control statements, if conditioning and switch case. First is the if conditioning. The if statement checks the specified condition and executes the following statement if the condition is met. Its syntax is if, open parenthesis, the conditional statement, then close parenthesis, and enclosed in the curly braces are the statements to be executed if the condition is true. In this example, the if conditioning is used to turn the LED on whenever the button is pushed. Next is the switch case, which, like the if conditioning, executes the following statements if the condition is true. Only in this case, a switch statement compares the value of the variable to multiple case statements and executes the statements under the case statements that matches the value. This example is similar to the previous one but uses the switch case to turn the LED on if the value of the button is 1 and off if it's 0. Then we have the for loop, which is used to repeat a block of statement as long as the condition is true. The loop is usually terminated by incrementing or decrementing the value of the variable in the condition. The syntax for the for loop is for, open parenthesis, the variable, the condition, and the increment or decrement, then the statements to be executed enclosed in the curly braces. In this example, the for loop is used to slowly increase the brightness of the LED if the initial value is 0, and slowly decrease the brightness if the initial brightness is 255.
That will be all today. Thank you for listening and goodbye.